A very good morning, my dear students. Today we will be starting with a new chapter, that is heat. Now, we have already learned about this chapter in the previous class as well, but we'll just go through into some further details in this class. So, what is heat? Heat is a form of energy. What is heat? Basically, heat is a form of energy. And that energy gives us the sensation of hotness or coldness, isn't it? Okay. So, what is heat? Heat is a form of energy that gives us the sensation of hotness or coldness. Now, this is a basic thing that we have learned in the previous chapter. Now, it is a form of energy that gets transferred. It is a form of energy that gets transferred. When will it get transferred? It will get transferred when two objects at different temperature when two objects which are at different temperature will be placed in contact or when connected through a conductor. Now, what is a conductor? A conductor is something that allows the heat to pass through them. Right? So, what is heat? Heat is a form of energy that gives us the sensation of hotness or coldness, and that energy gets transferred. That energy gets transferred from one object to the other. When the two objects at different temperatures are placed in contact or are connected through a conductor. Okay? Now, you must have experienced, some of you, not all, but you may experience it. Suppose when you place something to be cooked in a pan and place it on the stove, and then you place a steel spoon in the pan and heat it. The pan gets heated up along with the food in it. If you touch the spoon, that also feels hot. So, your body is at different temperature, the spoon is at different temperature, and the pan is at different temperature. So, when they are heated, when heat is being supplied, the flame of the heat is at different temperature. So, that is why the heat from the flame gets transferred to the pan and then ultimately to the food, because they are placed in contact. Now, that heat gets transferred to your fingers when you touch them through the spoon. That spoon is now acting as the conductor, because the spoon is also kept in contact. Even we can, if you keep a metal wire and then if you touch it, it will feel hot. Or if you take a steel scale and heat one end of the steel scale in a flame, you will feel in some due course of time that the other end also starts feeling hot. Why? Because the heat is getting transferred, because there is a difference in temperature in the two ends of the scale, and the scale is a good conductor. It allows heat to pass through them. Okay? Now, you may be asking, will it continue transferring? Will it continue transferring? No. It will stop transferring, or even if it transfers, we will not be able to notice it when till thermal equilibrium is obtained. Now, what is thermal equilibrium? when the two objects acquire the same temperature. So until and unless the two objects which are kept in contact acquire the same temperature, till that point of time, heat will keep on transferring, heat energy will keep on transferring from one object to the other when the two objects are kept in contact. Now in which direction will the heat get transferred? From the hot body, that is which is at higher temperature, to the cold body which is at lower temperature, and it will keep on transferring. This is the direction of transfer, and it will keep on transferring until thermal equilibrium is obtained. And what is thermal equilibrium? Just now I have said that these two bodies will acquire the same temperature due to the transfer of heat, because if heat transfers from hot body to the cold body, it will show a fall in its temperature and the cold body will show a rise in its temperature. So there will be a point of time when the two bodies will obtain the same temperature. Until that point, the heat will keep on transferring. Now, what is this temperature all about? We have learnt in the previous class. What is temperature? Temperature is the degree of hotness or coldness. Right? Temperature tells us in which direction the heat will get transferred when the two bodies will be kept in contact. Okay? So we need to measure temperature. So when we measure temperature, what do we use? We use a thermometer. We have learned for measuring the temperature of human bodies, we use a clinical thermometer, and for others we use a laboratory thermometer or a maximum or minimum thermometer. So when we measure temperature, we express them in units. And what are the units? Degree Celsius or degree centigrade, degree Fahrenheit and Kelvin, where Kelvin is the SI unit of temperature. Okay? Now, we can interconvert the temperature of a body in one unit to other units. For example, we have learned about converting meter to centimeter or kilometer. Similarly, these units are also interconvertible. And what are the different formulas? One is C by 5 is equal to F minus 32 by 9. Now this particular formula can be written in two forms. If you make C the subject, 5 will be here for multiplication. So C is equal to 5 getting multiplied. So 5 by 9 into F minus 32. And if you make F the subject, 9 will be transferred at first. So 9 by 5 C and then plus 32. 9 by 5 into C plus 32. Okay. So these are the two formulas when you can interconvert the values. If it is given in Fahrenheit, you can find it in Celsius. If it is given in Celsius, you can convert them in Fahrenheit. And another formula is in Kelvin. Now suppose you are asked to convert Kelvin to Fahrenheit. Now for Kelvin to Fahrenheit there is no temperature, but we can convert Celsius to Fahrenheit by using this formula. So you can substitute the value of C with this formula. Then it will be K is equal to 273 plus this 5 by 9 F minus 32. Understood? Now the exact value is not 273. It is actually the approximated value. It is 273.15 or 273.16, which can be approximated and be written as 273. Understood? So it's better that you go for the exact value, that is 273.15. Okay, so you may pause the video here and write the formulas for finding the different units of, or for converting different units of temperature. Okay, we have learned about conversion of different units of temperature in the previous class as well, but in this class we'll practice some more numericals which will be given as your assignment. Okay, if you have any problem, you may call me up and clear your doubt. Okay, now if we heat a particular object, or if heat is getting transferred from one object to the other, what are the changes that we will see if heat is getting transferred? Firstly, just now we have discussed that is a change in temperature. Now why will it happen? We have learned that any state of matter has molecules in it and they are always in a continuous random motion. And when a matter gains heat, that means heat energy is getting transferred to that state of matter, what will happen? The molecules will start vibrating faster, right? And if they start moving faster, they will have more kinetic energy. More kinetic energy because the molecules starts moving faster than before when they gain heat energy. And if it is more kinetic energy, that means it will show a rise in temperature. Now you may ask, what if the matter loses heat? What will happen? The molecules will start moving slower. That means less kinetic energy. Why? Because we have learned that kinetic energy is the energy possessed by a body by the virtue of its motion. So if the molecules start moving slower, that means kinetic energy will be lessened. So the molecules move slower, and due to it, it will show a fall in temperature. So that is why when a hot body and a cold body is kept in contact, heat energy gets transferred. So heat energy, the hot body loses heat. So hot body will show a fall in temperature, whereas the cold body receives heat because heat energy gets transferred from the hot body to the cold body. So the cold body, when it gains heat, it will show a rise in temperature. Okay, so this is the first change that we will observe when heat gets transferred, that is a change in temperature. Next is change in state. Change in the states of matter, that is from solids to liquids to gas, and vice versa, gases to liquids, liquids to gases, liquids to solids. Okay, so we have learned about this. When a solid is heated, it changes into its liquid form, and the process is called melting, and that takes place at a particular temperature, and in that particular temperature the solid will convert into the liquid form, and that particular temperature is called the melting point. That is, melting point is the temperature at which a solid, when heated, changes to liquid. Now if you heat the liquid, it will change into its gaseous form or into its vapor form. Now, if it changes into its gaseous form, then it is boiling. That means we are applying heat energy, more heat energy to fasten off the process. So that is called boiling. And if it gathers heat from the surrounding, then it will change into its vapor form, and that process is called evaporation. Now, this evaporation process will happen at a temperature below the boiling point. And what is boiling point? Boiling point is the fixed temperature at which, when a liquid is heated, is changed into its gaseous form. Now, is heated, that means we are applying heat energy externally from a source. But if we do not apply any heat energy, if the liquid itself gathers heat from the surrounding, then it will convert to its vapor form. It will convert it into its vapor form, but this conversion will happen at a temperature below the boiling point, and this evaporation process is a very slower process. But this boiling is a fast process. Right? Okay. Now, if a gas is cooled, it will change into its liquid form, and the process is called condensation. And the fixed temperature at which this will happen is called the condensation point. Now, if you again cool the liquid, then the liquid will change into its solid form, and that process is called solidification or freezing. And the fixed temperature at which the liquid form will change into its solid form is called the freezing point. For example, water. Let us take examples. Ice. Ice gets converted to liquid, that is water, at which particular temperature? 0 degrees Celsius. And at this particular temperature only, 0 degrees Celsius water will convert into 0 degrees Celsius ice by freezing. Again, this water will convert into the gas when we boil it at 100 degrees Celsius. And at 100 degrees Celsius only, the gaseous state will convert into the liquid state water. Okay. Now you may be asking, what if the water changes into its vapor form, that is water vapor? So it will change into water vapor at a temperature below the boiling point, that is below 100 degrees Celsius. Understood? So the temperature of water vapor is always less than 100 degrees Celsius. But when we boil water, it changes into gas, that is steam, at 100 degrees Celsius. Okay? Now, there is some substances that do not change into liquid state from solid. It directly changes into the vapor state. There are some solids, when they are heated or when they acquire heat energy, they do not change into liquid and then to vapor or gas. Rather, it changes directly to the vapor state, and that process is called sublimation. Okay, that process is called sublimation. For example, camphor, naphthalene, ammonium chloride, iodine, dry ice even. And that vapor state of that solid, when they are cooled, they do not change into liquid and then to solid. They directly change into its solid form, and that process is called deposition. Understood? Okay. So this will be all for today's class. You will have to go through your book till page number 70. Till page number 70. Okay? From the beginning of the chapter to page number 70. Go through that portion thoroughly, and if you have any problem, you may call me up or we may have a discussion in our online class through Google Meet, which we will be starting very soon. So this will be all for today's class. Go through the chapter, and whatever assignments you will get, just solve them. Okay? So thank you children for attending the video session. We'll be discussing a bit more about another change that we will see when heat gets transferred in the next class. Till then, stay safe, stay healthy. Not till then, but stay safe all together, all the time. So, thank you.